big data visualizations, it's actually not just a problem of quantity, it's also a problem of quality. Meaning that even if you had unlimited computing power, it is very difficult to visualize millions of your data points in a meaningful way. What are the problems? Well, the first would be overplotting. Overplotting will occur that some data points will occlude other structures in your data. You can try to solve that by decreasing your point size and maybe revealing more structures in your data, but there's a limit to how much you can decrease the point size. You can also maybe add a transparency effect, and that may reveal the more smaller, denser distributions hiding in your data, but it also makes your broader, more sparse distributions completely disappear. Another problem is if you can't plot everything together because it causes too much occlusion, then you will have to sample it. But if you will sample it, you will probably be biased to the more popular, more frequent distributions in your data. But in visualizations, you also want to see the outliers. So it is very difficult to navigate this kind of visualization. So today I'm going to cover Datashader, which is an open source Python package which aims to solve this kind of big data visualizations in a very clever, sophisticated way. I hope you will enjoy. Creating interactive plots for millions of data points is a bit much for my personal computer, so I'm going to use Saturn Cloud today to host my notebook on the AWS cloud server. So these machine specs should be enough, but I don't have that. But you can go nuts here and have about 0.5 terabyte of RAM if you need it. So you just host your notebook here, and from there on out, it's just a regular Jupyter notebook with some environment already included. Very convenient in my opinion. So today I'm going to work with the NYC taxi data. It's about 11 million sample points of coordinates of pickups and drop-offs of taxis in the New York City, and this will be our visualization challenge. In addition to Datashader, I'm also going to use Bokeh to make the plots interactive. If you don't know Bokeh, I've already made a video about it. You're more than welcome to take a look. Okay, so at first we just define general parameters for the Bokeh plots, and we define a general function to make an arbitrary Bokeh plot here. A disclaimer, most of this code was already beautifully written by the official Datashader example repository, and I've just made very small changes to make the notebook more visible. Okay, so the first approach would be to sample 1,000 points from the 11 million points and take a look at the general structure of the data. So we add the tile of the map, which is a cool feature to actually make the coordinates sit upon the real New York map. So this is how it looks like. And you can see that most of the points are concentrated in this region because probably these are the most popular pickup and drop-off points for taxis in New York City. But I doubt that this representation really shows how the data behaves and what's really in this 11 million sample points. So this is a problem of undersampling when there's a bias towards the most common points. The next natural step would be to try and plot more points to see more structure in the data. So let's try that. I'm gonna plot 10,000 points now, and we really can see new points in different areas in New York for pickups and drop-offs, but the Manhattan area seems already overplotted, so that's like a giant blob of points. And now we can use Bokeh for its interactive abilities to zoom in a bit, and zooming in helps. We can see the points a little bit better now. But now here's the question. Everything already seems very uniform inside Manhattan. Are there no different distributions inside Manhattan? And it's very difficult to see now. And if we make the dots smaller or more transparent, then we will completely lose sight of the other data points outside of Manhattan. So we can already see the problem of overplotting. Let's take a more extreme example. And I remind you, that was 0.1% of the data. 10,000 samples from 11 million. Now let's plot 1% of the data. So this takes a little bit more time to load. So Bokeh already did a little bit of scale up in order to see all the points, and we can already see the problem. So because there are so many points in Manhattan, the points were made much smaller, and in very dense areas in Manhattan maybe we can see some of the data points, but for other areas it's practically invisible. Maybe I can see in my screen, but probably you in the video don't see the points here at all. So that's a problem. Let's see how Datashader can help us solve it. Datashader approaches this problem in a very innovative way. So the trick here is not just to project the data points, but to aggregate them in a way that will make the most use of your display capabilities. So instead of just projecting the data points, we're not focusing on each individual point, we're trying to focus on how to visualize the pixels. So if we aggregate in terms of just the count, so a certain pixels will get the value of the count of the data points which were projected to that specific pixel. So you can try and look at it as the best resolution heat map you can get for your projection in your display. At least I hope I understood it right. And you have a lot of freedom in choosing that aggregation function. The most natural one would be to count the number of points that landed in that specific pixel. Let's see how it works. So we import Datashader, and then we create a canvas like every plotting library, and then we specify how to aggregate the points. So we define points from the data frame, and we specify the columns which include the points, and then we choose the aggregation function, which, as I stated, the most intuitive in my opinion would be to count the number of occurrences in a certain pixel. And then we have to shade the actual result according to the aggregation function, basically just coloring the image, and you can choose in what way to map the values to the colors. So if you specify linear, the most highest frequency pixels would be dark blue, and the least frequency would be white, and this transformation would be linear. So let's see the result. So now we're plotting all the 12 million points, and it looks like this. It doesn't look good, I'll explain why, but let's see. We do see the most dense points inside Manhattan, which we couldn't see before. The dots are really small, and we can't see any other points in other areas of New York. But let's understand the key differences here. We're plotting all the points. The data point size was selected automatically. Same goes for the transparency. And this is something that we couldn't do with Bokeh. We had to choose those things manually. Okay, so the problem is that this linear transformation is a bit too aggressive, and it really diminishes all the least frequent values. We can take a look at the histogram and see that this is exactly the case. So we have many probably pixels in Manhattan which have high occurrences, but for other areas the occurrence is much lower, so most of the linear range is wasted on these pixels. So let's see how can we improve that. A common solution will be to just equalize this histogram. So those of you with backgrounds in image processing know this operation quite well. We equalize the histogram to give more emphasis on the less frequent values. And now if we visualize the plot, it looks much better. Now we finally can see a representation of every point in the data. So we don't lose the less frequent data of other parts in New York, and we can also see the high density drop-offs in Manhattan. And now for the first time we can see something very interesting here. We can see that this area here are extremely smudged with a lot of noise, and there's actually a reason for that. There are many tall buildings here which disrupt the GPS accuracy, and this, just try to imagine how would you find that this pattern occurs here if you didn't have this quality visualization to pop it up. Now for the coolest part of this video. Did you notice how fast we rendered this image? it's almost instant. It takes about a second to make this kind of Datashader images. It's because the backend is very highly optimized to make this kind of images. And now maybe we can make this kind of rendering in real time using Bokeh interactive plots. So what we can do is we'll improve the visuals a bit. We'll make a black background with a better color map. And now we'll make a function which creates this kind of Datashader images. And now we'll pass the function to the interactive image by Bokeh. And that means that Bokeh, when we zoom in, can render these for each new image that we ask. So this is the same image, just with better colors. And now when we use the zoom in option, we can specify a region, zoom into that. And now Bokeh will make a new Datashader image, but he will use it regarding the values that they see here. So now we can see the hotspot in this area, which we couldn't have seen when Manhattan was in the picture. So this is great. In this resolution, we can already see the individual points. And as you can see, they are represented as pixels and not as points. So let's zoom out. So the more points we include, the slower the computation. Now we can maybe focus on this dense area of Manhattan, get a better look at it. So now the Datashader image will be rendered just for this area in Manhattan. And now we can see a better high resolution image of what's going on here, and see if maybe inside this dense area we can see there are even more denser areas and regions for drop-offs in. So this is really great. Let's add another layer of visualization to it and make this kind of interactive plots with the actual map of New York. So now we can add the area names to our insights and explore a bit. So maybe if we zoom into here, and now we can see there's kind of a hotspot here, so we can zoom into that, and we can see there's a cemetery here. So maybe this is the place where the parking lot for unfortunate events where you have to go to a funeral. But now we actually see it very clearly. And there's a certain area here in this region that maybe you guys from New York know what there is here, but it seems there's a lot of pickups, drop-offs in this specific area. And what more can you ask for? You can analyze each region in whatever resolution you want. And for this 16GB RAM machine, it renders quite quickly. It gives a very good representation of the different densities of data points in this map. One last eye candy, just to show you how far we can push the quality of these visualizations. You can also make plots on top of each other, which have different tasks. So what we're gonna do here, that we're gonna color in red the places where the taxi pickups were more frequent than the drops, and we're gonna color in blue the opposite. So, and we're gonna overlay these images on top of each other. We're gonna use the same interactive image, and let's see the result. So this is what we have, and now we can see this shows a different pattern. We can see that these vertical lines seem probably better to get picked up by a taxi, and these horizontal lines are more frequent for dropping off in taxis. And maybe in a different area here, you can see that these main roads here are more popular for taxi pickups. Maybe they are the main streets in this area. I'm not from New York, so I don't know, but it seems like it, like these are the main streets in this area, and these areas here are more for drop-offs, probably a more residential area and a more commercial area. So this is a new way to look at this map and gather more insights about what's going on here with the pickups and drop-offs. So this is amazing, and I really don't see how you could have gotten this quality insight in any other way other than you actually using the 11 million points that you had of these samples and actually being able to see all of them represented in this visualization. Can you believe that Datashader is an open source package? It's pretty amazing what developers contribute to the open source community in Python. The synergy with other packages like Bokeh and Pandas, everything works seamlessly. Thank you guys. So I hope you've enjoyed this video. I make this kind of video every week. Please tell me what you think in the comments. If you have anything you want to see, please ask me. This video is a request from one of you guys. I want to make this content as relevant as possible to you, and I hope I'll see you next week.